In this lesson, we're going to be revising the key probability concepts from grade 10. Okay, now in grade 10, you studied Venn diagrams. Okay, you studied Venn diagrams, and you focused on very, very important words, and words such as inclusive. You looked at exhaustive. You looked at the word mutually exclusive, all these important words, mutually exclusive, and you also looked at the word complementary. Okay, now these are key concepts in grade 10, and they relate to Venn diagrams. In the grade 11 year, you do more advanced Venn diagrams, and you are assessed on this in grade 12. So it's absolutely essential that we always revise and bring together all these concepts of Venn diagrams. Okay, now I'm going to use 4 examples to go through the most important concepts in grade 10 Venn diagrams, which you need for later. If you are struggling with any of these concepts, or it appears to be too quick, the lesson, you need to go back to the grade 10 lessons on probability. But when you're in 11 and 12, you're going to need this, so we're going to revise it, and we're going to revise it thoroughly. Okay, I'm not going to go into all the detailed explanations. I'm going into the main concepts and capturing them. That you can get in the grade 10 lesson. So let's go through some revision of grade 10 Venn diagrams. Let's look at a first example quickly here. Well, in the sample space, we've got 2 events, A and B. So A is the event, A and B. Okay, these we're taking the first 6 letters of the alphabet, and event A is going to contain little a and little b. Okay, event B will contain C, D, E, and F. Now, what do you notice about these events? Okay, well, firstly, the most important thing is that they are mutually exclusive. There is no intersection between, there's nothing in common between event A and event B. Okay, and we're going to relate some important probabilities to that. They are also exhaustive. Okay, they're very exhaustive. It means that all the elements of the sample space are contained in A or B. Okay, so it's in the union. And remember, if you talk of A or B, that was the union. And what is A and B? That's the intersection. Okay, if you remember those key words there. Now, in the union would be basically the whole sample space. The union would be A, B, C, D, E, and F. So the union is really A, B, C, D, E, and F. But the intersection, there's no one there. There's nothing in the intersection. Then we spoke probabilities. Now, remember, with mutually exclusive, the probability of obtaining a letter of the alphabet, the first 7, in the intersection is 0. There's 0 chance out of the 6. So for mutually exclusive, the probability of A and B is 0. For exhaustive, it means that all the elements of the sample space are contained in the circles. So the probability, if you remember, of A or B is going to be, there's 6 in the union. Look there, there's 6 elements out of the 6 in the sample space, which gives you 1. So for exhaustive, the probability of A or B is 1. That's very important. So mutually exclusive, the probability of the intersection is 0. Exhaustive, the probability of A or B, the union, is 1. Okay. Now, when events are mutually exclusive and exhaustive, they've got to be exhaustive. They contain all elements of the sample space in the circles. The events contain all of the elements of the sample space, and the events must be mutually exclusive as well. It means that there must be no intersection. When that happens, they're complementary. And what we often do in the world of probability, we refer to the set B. This set B can be referred to as A complement, or the other thing that you can say is what's not in A. What is not in A would be C, D, E, F. In other words, B is the set that's not in A. B contains everything that's not in A. Okay, that's A complements, not A. And A and B are complementary because they're mutually exclusive and at the same time exhaustive. Okay, now let's have a look at another example to highlight the rules of Venn diagrams. Now notice here you've got an intersection. So what is in the union here, A or B? The union is everybody, A, B, C, D, E, F. All 6 letters are in there. What is in the intersection? Wow, that's B. We've got an intersection there. So the events are what we call inclusive. They are inclusive. There is an intersection there. And what is the probability of A and B? Well, that would be 1 out of the 6, which is definitely not equal to 0. So when the probability of A and B is not 0, they're inclusive. There is an intersection. Okay. Then what about if you look at exhaustive? Well, definitely all the elements of the sample space, all of the 6 letters are contained in between the 2 circles. Okay, so the probability of A or B would be 6 out of the 6, which of course is 1. Again, exhaustive has got to do with the probability of A or B being equal to 1. Inclusive is where the probability of A and B does not equal 0. Okay, there we go. Are they complementary? They're not complementary because look, even though the sets are exhaustive, they are not mutually exclusive. They're inclusive. There is an intersection. The first example here is where you've got complementary sets. Okay, now that's important there. Okay, so they're not complementary at all. Okay, now let's have a look at a third example quickly. If we have a look at this, well, here we've got a very interesting situation. We've got events, a 7th letter added in. So your sample space has got the letter G in as well. A and B do not contain all the elements between them of the sample space. G is on the, when you get an outsider outside the circle, then the events A and B are not exhaustive. They don't contain all the elements. Okay, so what is the union? Very important. The union would be A, B, C, D, E, and F. That's everybody inside the circles. G is on the outside. What is the intersection here? A and B. Well, there's no one there in the intersection. So what are the events? The events are mutually exclusive. There we go. And what is the probability of A and B is 0. It's 0 out of the 7, which is 0. Remember, we're including G now. It's the sample space has got A, B, C, D, E, F, and G. So automatically the intersection is 0. And they're not exhaustive. Why? Because the probability of the union is 6 out of 7, which does not equal 1. If you remember that there's an element on the outside. So exhaustive means the probability of A or B, the probability of getting anything in the union is 1 because everybody's inside. Okay, so the G's on the outside. So these guys again are not complementary, because if you're complementary, you've got to be mutually exclusive and exhaustive, which is not happening here. Okay, let's look at a 4th example quickly. Now we've got an intersection, so they're definitely inclusive. That's an inclusive. And exhaustive, they're not exhaustive, so let's write down not exhaustive here. That's important there because there's a G on the outside. What is the union? The union would be all the elements A, B, C, D, E, and F. G's on the outside. The intersection is the set, it contains B there. So inclusive, because the probability of the intersection is definitely equal to 1 out of the 7, which is not equal to 0. Inclusive means the probability of A and B is not equal to 0. Not exhaustive, because the probability of A or B is equal to, it's going to be 6 out of 7, which does not equal 1. 1, 2, 3, 4, 5, 6 out of the 7. So these are the key features there. So remember, when you take the probability rule, A or B is equal to probability of A plus the probability of B minus the probability of A and B. Okay, remember 2 things happen here. If that equals 0, then we're talking about mutually exclusive. If that intersection does not equal to 0, we're talking about inclusive. And when the probability of A or B is 1, then we're talking exhaustive. And when you talk exhaustive, and mutually exclusive, you're talking complementary. Okay, that's so important there. Remember, this has got to do with the intersection, and that's got to do with the union. That's what's in both circles and what is common to both circles there. Okay, let's have a look at one final concept, then we're going to do a practice example. Okay, guys, just quickly, something about complementary. You'll notice if I said to you, what is the set not A? Well, what is not in A? It's the whole of B, and we often write that as A complement. So that would be A complement. Everything that's not in A is in B. So these events are complementary. They're mutually exclusive and exhaustive. Okay, but look at this here. If I said to you, if you look at A and B are not complementary. Can you see that they're not complementary because they're not exhaustive? Okay, they're mutually exclusive but not exhaustive. Okay, if I said to you what's not in A though, okay, what is not in A? Well, it's the whole of B and G. So we have a new set that we can call not A. Can you see that there? That blue set that I've circled there is not A or A complement. Okay, so not A is A complement, and that would be C, D, E, F, and G. Can you see that there? So in other words, if you look at these two sets, A and B are not complementary, but most definitely A and not A are complementary. Okay, because why are they complementary? Because if you look at what's not in A is in the set A complement, which is B and G. So if you circle that, you've got C, D, E, F, G. So not A is C, D, E, F, G, and it's everything that's not in A. Okay, so remember, A and B are not complementary because they're not exhaustive. G's on the outside of B, but not A is a complement, is B plus the little element G. Now those are complementary. Okay, A and not A are complementary.